Okay, so we're going to do the next section, next group of problems. We're going to start with 31. Use the prime factors method to find the least common multiple of each group. So to find, one common multiple would be just to multiply the two numbers together. Of course, that's not the least common multiple. Okay, so we're going to use the prime factors method, which is on page 201. So just read it, see if we can make sense of it. Write the prime factorization of each number. Okay, we've done that before. So we're going to divide by 2, and we get 27. Okay, we can't divide by 2, but we can divide by 3. And that'll give you 9. 27 divided by 3 is 9. You can divide by 3 again, and we get 3. So our prime factorization of 54 is 2 times 3 cubed, because we have 1, 2, 3 threes. Okay, divide by 2, and we get 15. Divide by 3, we get 5. Those are all prime numbers. So 30 is equal to 2 times 3 times 5. Okay. Choose all primes belonging to any factorization, with each prime raised to the power indicated by the greatest exponent that it has in any factorization. Okay. So what we have is we have 2, and we have 3 cubes. So we use 3 cubed, and then we have 5. So choose all primes belonging to any factorization. Okay, so we have 2, 3, and 5, with each prime raised to the power indicated by the greatest exponent. So that's going to be 2 times 27 times 5. 2 times 5 is 10. So that's going to be 10 times 27, which is 270. See if that's an answer or not. 270. Okay. Apparently I can follow directions pretty good. 34. 28. And 70. Prime factorization. Divide by 2 first. Keep dividing by 2 until you get an even odd number. In this case, our odd number is also a prime number. We do the same thing here for 70. So divide by 2, you get 35. Can't divide by 2, but we can divide by 5. And we get 35 divided by 5 is 7. So we can say that 28 is equal to 2 squared times 7. And 70 is equal to 2 times 5 times 7. So we take 2 times 5 times 7, 2, 5, 7, and we use the highest power that we have. We have 2 to the first power, 2 to the second, so we do 2 to the second. So we'll get 4 times 5 times 7, which is, well, that's 20. 4 times 5 is 20. 20 times 7 is 140. So let's see if that's correct. Yes, it is. Okay. Let's do 36, which is an even one, but it has 3 numbers. So we have 24, 36, and 48. Now, what does this mean, 140? Well, it means that if you take 140 and divide by 28, you get a whole number, which is 5. If you take 140 divided by 70, you get 2. It's kind of opposite of what we just did earlier. Okay, prime factorization first. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. Okay, so that's it with that one. 36 divided by 2 is 18. 18 divided by 2 is 9. Okay, it's odd now, so let's try 3. 9 divided by 3 is 3. Okay, we're done. 48 divided by 2 is 24. So we just got basically that part again. Okay, so now let's write the prime factor. Let's write these out. 24 is equal to 2 cubed, because we have 2 times 2 times 2, times 3. 36 is equal to 2 squared times 3 squared, and 48 is equal to 2 to the 4th, because we have 1, 2, 3, 4 2's times 3. So the only thing we have are 2's and 3's here. 2's and 3's. Okay, so we take the highest power, which is the 4th power for 2, and the 2nd power for 3. 2 to the 4th is 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 squared is 9. 9 times 16, I think, is 144. Let's just see what happens. 144. So, 144 divided by 24 is 6. 144 divided by 36 is 4. And 144 divided by 48 is 3. So that does work out right, and that is the correct answer. Okay, now we're going to do the same thing, but using the method of dividing by prime factors. So let's do the same 3 like we did just a second ago. Here we have 2 numbers, 24 and 36. So it's our 32. Of course, the other way you could do it is just multiply all the multiples of these and find out where you match up first. And so that's what we're doing here. Let's just demonstrate that. So 24 times 2 is 48, times 3 is 72, times 4 is, 96, times 5 is, let's see, 24 times 5 is 120. Okay, so let's do it with 32. 32, 64, 96. So that's what it means when you have the least common multiple. So the answer is 96 now. So that's kind of the brute force method of doing it. Just list all the multiples and find out the lowest one that matches up. Anyway, let's look for finding the least common multiple by dividing by the prime factors method. Okay. So let's just add another page here so we can, okay, write the 2 numbers in a row. 24, 32. Divide each of the numbers by a common prime factor. So divide by 2. And what we get is 12 and 18. Or no, we don't. 16. 12 and 16. Try, okay. I just keep doing this. So we can divide it by 2 again, which would give us 6 and 8. And we can divide by 2 again, which would give us 3 and 4. Okay, divide the quotients by a common prime number. No prime number will divide all the quotients, but a prime will divide some of them, divide where possible, bring any non-divisible quotients down. The product of all the prime divisors from steps 2 and 3, as well as all remaining quotients, is the least common multiple. So basically it's saying this times this times this times that times that. Is that right? The product of all prime numbers in steps 2 and 3, as well as all remaining quotients. Okay, yeah. So we do 2 times 2 times 2 times 3 times 4. That's 2 times 2 times 2 is 8. Oh, get carried away there. Let's just plug, well, you can plug it in your calculator, but to get 8 times 3 is 24, times 4 is 96. which is what we got over here. Okay. So let's do 40. Oh, we got 3 in this case. Already starting with 3. That's okay. We can do it. Okay, so you list all the numbers in a row. 48, 54, 60. Okay, divide by 2. They're all even, so we can do that. So you get 24, 27, 30. This is 24, not 42. I got that. 24. Okay, I can't divide by 2 because they're all even. So can I divide by 3? Yes. Okay, so 24 divided by 3 is 8. 27 divided by 3 is 9. 30 divided by 3 is 10. Okay. We can divide these by 2, but we can't divide that by 2. We can divide that by 3, but we can't divide that by 3. So this is all we have left. So now all you have to do is take 2 times 3 times 8 times 9 times 10, which is a big number. 2 times 3 times 8 times 9 times 10. And I get 4,320. They're saying it's half of that. Okay, so let me think. What did I do wrong? I'm not sure, so let me just stop here for a second and try to figure out what's going on. Okay, well, interesting. So when you have 3 numbers, it's slightly different. Okay, I just realized that. We do have this one where 2 of the terms can be divided by 2. So what you do is you take this divided by 2, and this divided by 2, and this one you just bring down 9. So the one that's not divisible by, then you just bring it down to the next thing. So now we make our thing. So we have 2 times 3 times 2 times 4 times 9 times 5. 2 times 3 times 2 times 4 times 9 times 5. 2,160, which is the answer. Now, of course, this is a lot easier than listing all the common multiples, because if you think about that, 2,160 divided by 48 is 45. So I'd have to list 45 multiples of that before I would get to a common one. So this one, it's almost like, I can just list them, but in this case, you would have to have the list be so huge that this method works so much better. And because that's kind of different, we're going to do more of this particular problem because it's a little bit unusual. So we're going to do 41 and 42. So let's try it again. So we list the numbers. Okay, they're all even, so we can divide by 2. We get 8, 60, and 108. Okay, they're even again. So we divide by 2. You get 4, 30, and 54. Okay, they're still even, so I'll do it again. Divide by 2. You get 2, 15, and 27. Okay, well, that's as far as we can go with the 2. But these 2 could be divided one more time. They can be divided by 3. So we'll say divide by 3. This one we just bring down. And then 15 divided by 3 is 5. 27 divided by 3 is 9. And now we just multiply all these together. Well, let's put them all. We got 4 2's. So we have 2 to the 4th times 3 times 5 times 9. And 2 to the 4th is 16. So 16 times 3 times 5 times 9. 16 times 3 times 5 times 9 is 2160 again. Okay, let's look at 42. 210. 210. 385. 2310. Okay, well, they're not even, so we can divide by 5. So we know we can divide by 5. You can't divide by 3. How do I know that? Well, this one you can divide by 3 because you add 2 and 1. That's 3. Here we add 8 plus 3 is 11 plus 5 is 16. You can't divide that by 3. This one you could divide by 3. So those two you could divide by 3, but that one you couldn't. So we go to 5. 210 divided by 5 is equal to 42. 385 divided by 5 is 77. And 3,110 divided by 5 is 462. Okay, now is there another prime number? 5's not going to work because we don't end in 0 or 5. So 7's an option because this divides by 7, this divides by 7. 462 divided by 7, does that work? It does, so 42 divided by 7 is 6, 77 divided by 7 is 11, 462 is 66. Okay, so now 7's not going to work. The next prime number is 11. We have 11 here, and 66 can be divided by 11, but 6 can't. So we bring the 6 down. 11 divided by 11 is 1. 66 divided by 11 is 6. So we're done. So then we multiply all this stuff together. So we have 5 times 6 squared times 7 times 11. 5 times 6 squared, which is 36, times 7 times 11 is oh, wait a second. Well, we can do one more because we get to this point and we can divide the first and the last by 6, but not this one. So we bring this down and you get 1 and you get 1. So 5 times 6 times 7 times 11. 5 times 6 times 7 times 11 is 2310, which is actually this number. So this is the first multiple. 2310 divided by 385 is 6, and 2310 divided by 210 is 11. So that's interesting. So I thought I'd finished, but I hadn't finished. So as long as you have two numbers that can be divided by a common factor, even though this one originally wasn't, when you brought this down, these two did. So that worked out. Interesting. Okay, so we're going to close that and we'll start a new one.